Okay, good afternoon. I'm Amanatidis, and I'm a PhD student at the University of Cambridge. And today I will try to do my best and present the team's paper instead of the main author, which is Charlie Hewitt. And the paper is on assessing the public perception of self-driving cars, the autonomous vehicle acceptance model. First of all, I'd like to start by thanking the previous presentation because it was very interesting. We kind of have like some similar topics, and I'll try to kind of point it out as we go along in this presentation. So, as indeed mentioned in the previous presentation, there's vehicles with limited levels of autonomy are already coming up on the market. They already are on the market and deployed in different places in the world, in different environments. However, while there's clearly people who are buying these vehicles, there's little evidence to suggest that users in general kind of broadly desire the widespread use of autonomous vehicles. I mean, what I'm trying to say is we don't know if this is just a specific subset of users that are choosing to buy these vehicles or if this is a broader trend within the industry. More specific than that, most existing studies do not, of public perception of autonomous vehicles, do not use established user acceptance models, okay? And therefore it might be difficult to make comparisons or interpret the results of between these studies. For example, as this kind of chart shows, as the level of autonomy increases, basically, and the level of interaction between the user and the vehicle reduces, it is unclear exactly what part of that interaction is reducing. Is this, as the previous presentation meant, is it the hands that are taking off the wheel? Is it that not paying attention to auditory interactions between the vehicle and the user, or is it eyes and brain that are off? So what we're trying to do is basically, and what this paper tries to do, is establish a model based on previous user acceptance models that allows this evaluation and comparison between different studies. Okay, so our proposed approach is to unify kind of current efforts in measuring acceptance of autonomous vehicles, to combine the different elements between current technology acceptance models, car acceptance models, and kind of introduce our own element of autonomous vehicles and levels of autonomy. Furthermore, we believe that the concrete industry set levels of autonomy might not be intelligible to the average user, or might not be extremely kind of indicative of what the vehicle can or cannot do. So we want to enable participants to kind of better visualize these hypothetical technologies and how they're implemented in their vehicle. So as part of that effort, this paper presents the AVAM, which is basically the initials of our autonomous vehicle acceptance model, as presented in the beginning. So the AVAM is a 26-item questionnaire, which is basically an adaptation of two previous models, specifically the universal technology of usage and acceptance of technology and the car technology acceptance model. Okay, and I'm going to explain later specifically what parts we have adapted and what parts we've kind of added in. It uses 6 autonomy scenarios, so these represent a 0 to 5 level of autonomy, but they're not labeled level 1 or level 3 or level 5. Instead, it's an explanation that is given to the user of each level of autonomy. Finally, this model was first piloted with 54 people and then kind of developed with 187 participants. All taken through Amazon Mechanical Turk. Just a little bit about their characteristics. The average age is 22 to 65 years old, with a mean of 34 and a standard deviation of 9.2. We have 111 male and 76 female, so not quite 50-50, but getting there, and all of them have been taken from the US, and I will kind of describe a little bit at the end what this means in terms of the sample. And finally, and this is kind of important to us, the full data set is available upon request to everybody who wants to use it or include it in their research. Okay, so the questionnaire was established based on, as I said, the two previous models. It consists of some background questions to understand about what our users are, what their usage of the vehicle is. Do they have any previous driving experience? Actually, 181 of the 187 people did have a driving license and were driving. So the individual items were taken to correspond as much as possible to UTOT. That means that out of the all the 8 factors of UTOT were included, and then the 9th item was the last factor of CTAM, which is about perceived safety. And again, I'll explain that in detail. We kept also the 7-point Likert scale as per UTOT, and the 5-point Likert scale was introduced for the additional questions. So the additional questions, what are they? Well, as kind of explained, kind of given a little bit in the previous talk, it's uncertain, or perhaps it is uncertain, for users what elements, what level of attention they need to have when they're driving. Do they need to use their hands? Do they need to use their feet? Do you need to use their eyes? So basically, we added 3 additional questions at the end of the questionnaire to evaluate if users knew what part of their body, in a way, they needed to make sure that they're using during the driving at these individual levels. We used the term eyes instead of brain or mind because we thought that this might imply more complex engagement. So it's just feet, hands, and eyes. And also, I'd like to mention that the participants were had to answer the questionnaire 6 times, 1 per each autonomy scenario, and this was done in a row. Now, there's obviously trade-offs, and I think that was mentioned in one of the questions beforehand. At what stage do you answer the questions, and if you answer them in an order or not. We chose to do this in order, which might introduce some sort of bias in that, but the trade-off, the positive, if you will, is that it will basically allow users to kind of visualize kind of in increments, in hypothetical increments, the distance between where we are in the present in terms of technology and where we'll be in the future. Okay, so this is basically what I was saying beforehand. So of all these scenarios, there's one that proved to be particularly difficult, and that is level 4. And the reason why level 4 is particularly difficult is because the definition of level 4 in SAE standards is very broad and can be divided, if you will, in different ways. For consistency in this study, we used a definition that follows the specific type of roadway, so basically an extension of level 3. And by the way, ignore the text at the bottom. This is just kind of illustrative. This is not the text that we had actually in the paper. You can find that on the paper. Okay, so in terms of the results and what we're aiming for high internal consistency and external validity, obviously. And as you can see on the right-hand side, we had scores of over 0.8 on all of the, so this is on Cronbach's alpha, I should point out, on all the different factors that are constituents of the AVAM, and above 0.9 in some of them. In terms of external validity, we want to compare this study with Rödel and al. 2014. However, there are limitations because obviously the study at the time was not used a different kind of scale, didn't use SAE, and there were some differences between the questions, so we tried to kind of match that as good as possible. What ended up happening is that we had to exclude level 3 because that was not so the Rödel and al. Did not have the equivalent of what we now call SAE level 3 in 2014. Again, for the external validity, we couldn't quite fit it all in this very short presentation, so you can find that in the paper if needed. So having established this model, we went on to kind of evaluate some questions that we might use this model for. And specifically, the first three that we tried are these two you can see. How does the user acceptance vary with the level of autonomy of a vehicle? And which methods of control do users expect to have for vehicles with different levels of autonomy? So this is what I was saying about hands, feet, and eyes. So what you can see here, and hopefully this is not too small, is the result of the 9 factors that I described earlier of AVAM. Okay, so I'm not going to go through all of them because otherwise they'll take forever. But what we can see in these, so by the way, I should point out that higher is better for everything except anxiety, which obviously lower is better. So what we can see is generally a trend towards reduction of, say, performance expectancy or effort expectancy as we increase the level of autonomy. Okay, we believe that this may be because of lack of trust in users, but also because of the kind of increase in having to make a kind of a hypothetical guess about what this technology will be in the future. So people cannot quite perceive how this technology will be and how basically will affect them when they're driving. So this is particularly visible in things like perceived safety. While the vast majority of studies, for instance, recommend autonomy as a means to reduce accidents, it turns out that users kind of mostly disagree, and as the level of autonomy increases, perceived safety reduces, and we attribute that to uncertainty about what the technology is and how they perceive it. That's how the users perceive it. In terms of the second research question, the results were somewhat different. In this case, what we see is that the level of interaction between levels 0 and 4 remains relatively constant for hands, feet, and eyes, with perhaps a little reduction in terms of hands as we go along. But then there is a massive or a sharp drop between level 4 and level 5. Okay, we believe that this is because users are understanding the difference between level 5 and all the other levels. However, it seems like the difference between level 1 and level 4 remains uncertain in the eyes of a lot of the users. So this is basically what we wanted to highlight, one of the things I want to highlight with AVAM. So, kind of have to go a bit faster to conclude here. So partial autonomy is perceived to require uniformly high driver engagement with full autonomy. So this is clear from the last few graphs. The public is not yet fully convinced about autonomous cars, and they have some uncertainty, lack of trust, and they're anxious about some of these technologies. Also, perceived user engagement does not escalate clearly. Some engagement may be cumbersome, regardless of how often it is required. So we talked about, so we heard about handovers and takeovers previously. This is an example of that. However, there's a lot more work to be done. Analysis by age, gender, driving experience are yet to be concluded, and hopefully we'll do that in the near future. In addition to that, in this study we only used US participants. I think it would be interesting to see the difference between users from different countries and see if there's a cultural difference involved. Okay, so in conclusion, this was a standardized evaluation of autonomous vehicles. AVAM provides a standardized evaluation of autonomous vehicles across studies and a meaningful assessment of changes in perception over time, because you can redo the study over a few years to see if there's a difference. And similarly with different autonomous vehicle technologies, so different levels of automation. It provides high internal consistency and external validity. And the results of using that to the research questions was that participants generally are positive about autonomous vehicles, but with preference to lower levels of autonomy. The utility of autonomous vehicles seems to be more appreciated in level 5. And we hope that, and this is kind of extension to the rest of the room that findings should inform efforts in simplifying autonomous vehicle human-machine interfaces across different autonomy levels. Yeah, that's it. I'm Theocharis. Thank you very much. Any questions?
Actually, I will try pass the mics. I'll run around. So if you have questions, raise your hand. Anyone? Oh, yes, there you go. Yeah, say your name and your affiliation and question.
Hi, thanks for the talk. My name is Kai from LMU Munich, and I would like to ask about level 4. In the presentation before, we've seen that there is no takeover request. So if there's no takeover request, can you elaborate the difference to level 5 and level 3? Thanks.
Thanks for the question. So I think this depends on your definition of level 4. In some definitions of level 4, there's no takeover request. So for instance, if this is an autonomous vehicle that's only used within low speeds, say outside of normal roads, or if it's used within kind of a certain very kind of, not necessarily very, but somewhat constricted way. So for instance, it could be anything, weather, it can be roads, it can be speeds. Okay. In this case, we only looked at roads, and an example of that would be, for instance, that this vehicle is fully autonomous in all city environments. Okay, but it's not autonomous in highway environments. According to the SAE levels, that is level 4. It's not level 3, and it's not level 5 either. But you can apply that the same thing. For instance, an autonomous vehicle that is fully autonomous in any situation except, say, snow, and then has to be manually driven in snow. Or can be fully autonomous up to 80 kilometers per hour, but then has to be manually driven after 80 kilometers per hour. So there would be some sort of takeover between autonomous and manual. So that's half the answer. And the other half of the answer is that clearly we are discussing this here, and we like to think that we are experts in autonomous vehicles, right? People who are not experts in autonomous vehicles do not know the difference, do not know when, if they buy an autonomous, level 4 autonomous vehicle, do not know its capabilities and when they can use it or not. And I think that's perhaps what we're trying to kind of explain in the second half of kind of the research and the second question that we had.
Hi. My question is, if you already have everything on the US, I think it would be interesting to see where the people are in the US who have answered the question. Because I think, for instance, in Silicon Valley, if there's driving around a lot of autonomous vehicles, so it might be the scales for anxiousness or anxiety would be potentially different. That would be something that you could look into, whether the exposure to those types of cars will actually change anything to that.
Yeah, thank you for that. You're totally right. I don't think we have done a detailed analysis of like which city people live, but we definitely looked at sort of the environment that they lived in. If there was urban environment, if it was countryside, if it was suburbia, so this kind of sort of level. And we had a good representation of people in urban environments and suburban environments, a bit less so in rural areas, but they were still represented. So it's not as if all these people are in Silicon Valley, but it's also not that these people all live in Kansas or something. It's kind of a combination. Yeah, but I think you're right. There's potential to look at even more detailed level. Yeah, certainly.
Okay, so we are right on time. Thanks, speaker again.